In this video, we're going to use the sine rule to find side lengths of triangles. So what is the sine rule, first of all? Just a refresher on the previous things that you know. SOHCAHTOA is used to find the missing angles or sides in right-angled triangles. But what if we don't have a right-angled triangle with that 90-degree corner? What can we do instead to find sides and angles? So, as you've learned in the video for cosine rule, this sine rule can also be used to find missing sides or angles in a triangle, not just right angled ones. It can actually be used in a right angled triangle as well, these sine and cosine rules, but it's sometimes handier. The SOHCAHTOA is probably much quicker in some ways. Okay, so for the sine rule, what we'll need is two angle side pairs. And what we mean by that is if in one corner you have an angle, the opposite side to that, they would be a pair, and we need two of those. So here's the other example. Do remember that we do the side lengths in lowercase letters of the alphabet, and the size of the angles we use uppercase, and they're always the matching one. As you can see here, capital B and lowercase b will use the same. So finding a side, here is the sine rule, noticing what's where. So we've got at the top of the fraction on the left-hand side, a side over an angle, and it's the corresponding one, it's pair, if you like. And on the right-hand side of the equals, another pair, the side at the top and then the angle at the bottom. So three of these values will be known when we come to solve one of these problems. So for example, it will be two of the angles that you will know and one of the sides, leaving one of the sides unknown, that fourth unknown value, and we'll call that side A. The process that we need to work through, classic sort of process, draw a diagram, please. Draw that on your page so that you can then label the sides and the angles. You can write on that information. Then work out which of the four is unknown, and it might be you have to put in an X or an A. And then we put that in the top left position of the formula. That's going to be really important. Top left, let's remember that one. And then you substitute in your other values, rearrange and solve. Come back to these steps if you get lost in the future. Finding a side. So let's do an example. If we're asked to find the length of the missing side of this triangle, let's have a look at what pairs that we've got. Do some of those angles match up with a side across from it? We do here. We've got the 76 lining up with the X, so that's opposite. X is opposite 76, and 63 and 7 are opposite each other, so they're a pair. Here's our sine formula. We can stick with X, or you might like to label your triangle that X is the unknown, so you might prefer to call that little letter A, lowercase a, and therefore angle A is over at 76, and then the other ones are B, side length 7, and the angle is 63. Now let's substitute those into the formula. Where we see an A, we're going to put an X. And making sure that we're using it in the top left, as we mentioned before. You know, put the X over there. Don't make the X side B. Just makes rearranging a little bit trickier for you. And so then we substitute in the other numbers. Sine A, the angle for A was 76, as you can see, and that's what we've filled in here. And then we need to rearrange. So X is being divided by sine of 76. You multiply both sides essentially by that. And as you can see, that's what we've got written on the right-hand side of the equals here, the multiply by sine of 76, working that out to be 7.6 for X. What's its units? It's a side length, so it's centimetres. Let's do one more together. We're asked this time to find the length of BC, correct to three significant figures. So BC, that's a side length, so that's this side over here. That's the thing we're trying to find. So let's make that our unknown, our X or our A. Let's use A because that's the top left-hand letter for the formula. And then, well, conveniently, that is across from angle A as well. So that matches this naming. They've already given us angle B, letter B. So let's do its side opposite that, across from that is 5.6 for B. Let's write out our formula each time. No, that's wrong. We're starting with A over sine A is equal to B over sine B. And then substitute in your values. A we leave as A, little case a I mean, sine of A, so sine of 47. We say sine, I know it looks like sin, I guess it's short for that S-I-N-E. B is 5.6, and sine of angle B is sine of 29. Rearrange that where you multiply the numerator on the other side through by sine of 47 all over sine of 29. Working that out, it comes out to be approximately 8.45 it would round to on your calculator. What are the units? Centimeters. Does that match the question? It said 3 significant figures, which in this case is the first number before the decimal and then 2 decimal places. But it did say find the length of BC. It didn't actually say find little letter a. So it would be more appropriate to either write that is also equal to BC or a separate line saying BC is 8.45 centimeters. So make sure you go back and read the question that you were asked to make sure you're answering that correctly. There are some questions to do. Thanks for joining me.